Welcome to The Explainer, where we break down big topics using clear, focused slides from our source material. Today, we're tackling something huge, a technology that might just reshape the entire global energy landscape. We're talking about small modular reactors. So, let's kick things off with a massive question. How do you power a $30 trillion economy cleanly? Think about it. You've got ambitious countries like India aiming for absolutely incredible economic growth. But here's the catch. They have to achieve all of that while decarbonizing their entire energy supply. It's a huge puzzle. And this isn't just one country's problem. We're really talking about a global energy challenge. The whole world is hungry for clean, reliable power. The entire global energy system is at this critical turning point. Electricity demand is set to just skyrocket, but at the same time, the pressure to hit those net zero targets is getting more intense every single year. And if that wasn't enough, just think about our digital world. The explosive rise of AI, all those massive data centers, our digital everything. Well, it's incredibly power hungry. All of this is putting an unprecedented strain on our conventional power grids, pushing them right to their limits. It's forcing us to find new, much more robust energy solutions. So how in the world can we meet this skyrocketing demand? Well, one answer that's gaining some serious momentum is a completely new take on nuclear power. Okay, let's dive in and really look at this idea of nuclear power reimagined. We're talking about small modular reactors. Now, when you hear nuclear, you probably picture those gigantic, sprawling power plants, right? Well, these are not that. SMRs, as defined by the International Atomic Energy Agency, are way smaller. They're advanced fission reactors designed to produce up to about 300 megawatts each. For perspective, a traditional plant is often over 1,000. And here is the big idea, the real game changer. The whole philosophy is to stop thinking about nuclear plants as these massive, one-of-a-kind construction projects that take decades to build. Instead, the idea is to build them more like cars on an assembly line. You shift to a streamlined factory process, mass-produce the components, ship them to the site, and assemble them quickly. So let's put them side by side. On the one hand, conventional nuclear, and on the other, small modular reactors. The difference is pretty stark. SMRs are smaller, you can build them much faster, and, this is really key, they often have what are called passive safety features. Basically, that means they can shut down using natural forces like gravity, without needing external power or someone to flip a switch. It's a fundamental difference. So theory is great, but let's see what this looks like in the real world. For that, we can turn to India's SMR strategy. It is an incredible case study in just how much ambition is riding on this new technology. Just look at this number, 100 gigawatts. That is India's target for nuclear power capacity by the year 2047. It's a core part of their Viksit Bharat plan, which is this grand vision for becoming a developed nation. And to do that, they know they need a massive amount of clean, reliable power. And this isn't just talk. They are putting serious money behind it. The government has allocated 20,000 crore rupees in the budget to create a brand new nuclear energy mission. And its main focus, you guessed it, research and development for SMRs. And this slide really illustrates just how official this commitment is. This graphic, right from the union budget, ties that huge investment directly to a concrete goal: getting at least 5 domestically designed SMRs up and running within the next decade. That's a really aggressive timeline. Now, India's push is part of a much, much bigger global trend. You can see here that countries all over the world are developing their own SMR technologies. Russia and China already have some operational. Canada is in the construction phase, and then you have the US, the UK, and others deep into the licensing and development stages. It's a global race, for sure. But of course, deploying a brand new technology like this is never a simple plug-and-play operation. There are some significant hurdles to overcome and some real challenges on the path to actually getting these things deployed at scale. So what are we up against? Well, first, you've got the regulatory and policy hurdles. Then there's the high initial capital cost. These things are not cheap to get started. You've also got bottlenecks in the fuel supply chain, especially for this new kind of advanced fuel called HALEU that a lot of SMRs need. And of course, you have to manage the waste and critically earn public trust and address safety concerns. Okay, so those challenges are real. But the good news is, people are already working on some pretty innovative solutions to pave the way for this nuclear future. So let's talk about the road to deployment. Now, this is one of the cleverest ideas I've seen. It's called the coal to nuclear transition.
The idea is to look at all these old, retiring coal-fired power plants not as a liability, but as a massive opportunity. I mean, think about it. The most expensive infrastructure is already there. You've got heavy-duty transmission lines ready to plug into. You have cooling water systems in place. And you have a whole community of skilled energy workers who can be retrained. By building SMRs on these brownfield sites, you can slash project costs by a staggering 15 to 35%. That is huge. So ultimately, making this happen is going to take what you'd call a whole-of-government approach. You've got to reform laws to let private companies invest. You need to work with other countries on technology and safety. You have to invest in public awareness to build that trust. It really requires a huge, coordinated effort to create the right ecosystem for SMRs to succeed. When you look at the big picture, the expert consensus seems to be that even with all the hurdles, SMRs could represent a true paradigm shift. They could be the cornerstone of the next generation of energy infrastructure. So I'll leave you with a question to think about. As we look at this future potentially powered by tiny nuclear reactors, what do you think is the biggest promise? And what's the biggest peril?